So now we continue in our lecture with big data and what is the definition of big data. And in all honesty, everybody's got a different definition. But the simplest description of it is basically that big data is a subset of data science that goes beyond traditional processing technologies. Because there is a difference between the data you have on your laptop and versus what people are doing in industry. The thing is, we also look at supervised and unsupervised data, and that's data that we specifically are looking for certain things, and data that already exists and what can we do with it. Whereas supervised data is more about specific experiments we want to go to. The thing is, looking at data for things like Medicare fraud, I don't know what it is, but I have this set of data, so I start looking for patterns and correlating it to how fraud takes place. The thing is, some of the key concepts is, ultimately you have an objective and a goal, and that's going to be dictated by time, money, and people. That's the basics of project management. And so, once again, yes, I know I'm repetitious, but it comes down to creativity and understanding certain things. The thing you have to be, and what you're looking for, are also the attributes. What's driving this data? What are the key factors? Yes, we're getting back into design of experiments and conjoint. The thing about data is when you stare at it too long, people start to make assumptions. If you stare at something long enough, you start to, excuse me, I think I'm starting to grow tiger stripes from the sun. But what it comes down to for data and marketing is it's about finding customers, getting customers, and growing customers. And so these are all the parameters that are associated with that. What has to it find? What has to it get and grow? And so what it comes down to is what you're trying to do as a business is you have goals, you're using data analysis, and it's a process of continual feedback, that what you learn from your data, you feedback and change it. And what all that data sits on are your 5 V's. What is it that you use data for? Well, a lot depends on what kind of timeline you're looking at. If you're looking at short term, then you're mostly looking for sales. If you're looking at medium term, then you're trying to build markets and build customer loyalty. And if you're talking about long term, you're looking at, okay, how do I keep my customers, but as well as and manage what's called the churn. And what the churn is do I need to get new customers? Do I keep my old customers? And I'm going to lose customers. I mean, that's a given. You will lose people. No company is perfect. And that's this churn of coming in, going out, and trying to hold on. And long term, those are the kinds of things that you worry about. Not only that, but you've already filled a bunch of buckets. So what are you trying to do? You're trying to find new buckets to keep growing. Some of the issues that people have to deal with is whether or not their data is too consolidated, whether or not they have the right tools to do it, how to get that noise out, and make sure that the data is legitimate. The thing is what it really boils down to is that if you can meet the requirements that you need of the 3 V's, then you're creating data that you can actually use. The thing is, this data affects every part of the sales tunnel. And the thing is, what you're looking also for are certain values to come out where you can expand your sales. Again, this is the age about trying to get the most out of every customer. And so, in terms of data techniques, we're looking at clusters, supervised data, and reinforcement. Clustering versus segmentation. Basically, segmentation is a proactive design, whereas clustering, you have this data and you're trying to find the patterns out. And we've talked about this before in terms of what functions impact, and you cannot find clumps of data together. This is in your book. I'm not going to go over it, but it's the definition of how mathematically they find clusters. Am I going to quiz you on it? Nah. I just want you to be exposed for it. And the big thing you see is these can get extremely complex. And so actually data visualization is actually a really big field. How can I take all this complex data, make it simple enough that people can see it and understand it? An example of this is like credit card fraud. And that's that criminal activity, you tend to form patterns. And criminals tend to form patterns. And so when you go off pattern, that's when your credit card company flags you. Now, some of these are really easy. Like, I got a phone call saying, I bought something at Albertsons, and then 20 minutes later, my credit card got flagged because somebody was trying to buy a leather bustier in Thailand. I get this phone call from my credit card company. Did you just buy a leather bustier? And it's like, no, it makes me look fat. But anyway, this is an example of what they do when they look at your patterns. Examples of supervised data is when you have techniques such as neural nets or regression where you look at the data. And so what you're actually doing is taking past data to try to predict the future. And so that's what they're doing, is projecting it. Now, what they use is something called recommender systems. And what they do is they use specific kinds of filtering to try to find out data and to pull it out. And so here are some of the techniques. If you're interested in it, what this is intended to do is to give you some background information. So you can go ahead and start. But essentially in terms of recommender systems, which are also reinforcement, what you're doing is there are 3 different techniques: collaborative filtering, content-based, and hybrid-based. No, hybrid is a combination of collaborative and content. And so what collaborative filtering is about is figuring out how to filter out the data that you actually need, and content-based is essentially you're looking at user profiles. And so the process they use is you collect and clean the data, you extract what you need. Once you extract what you need, you have to classify it. It's just like with you and your files. What do? You put them in folders. And so the big thing, though, is that when you do this analysis, one thing, again, you have to be careful about is your data biased, that you've arranged in such a way that you see what you want to see, or is it what's actually created and what's out there? And so in the next video, we'll wrap up the rest of our data lecture.